Now we know what exponential growth and decay look like on a graph and some of that language. Where would we ever use that? Finance. Finance is where you would use that when you look at real world situations. So that's what we're going to look at now. And you're going to see a common formula. And this will be on SAT, PSAT, so you really want to know this formula and what it stands for. And it looks like this. Y equals A times 1 plus R to the T power. So what does that stand for? A stands for my initial amount. My initial amount. R stands for a rate. It is your growth rate. And we know that a rate is like per. So just like slope, we have a rate in this equation. And T is going to stand for time. So those are the three things we want to pull out of our word problems. So it says the original value of an investment is $1,400. And the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. So this is a real everyday language that we use. So A is going to be 1,400. My rate is 9% each year, so it's 0.09. My calculator's not going to read percent, it's going to read decimal. So I put 0.09. And then my time is 25 years. So I'm going to plug that into my formula. Y equals 1,400, open parentheses, 1 plus 0.09 raised to the T power, which is 25. And here, I'm going to let my calculator do the work for me. So I'm going to go to my home screen, and we are going to type it in just like we see it, exactly like I see it. So I'm going to type in 1,400, open parenthesis, 1 plus 0.09, close parenthesis. Remember how I get that exponent? I do that caret top, and I type in 25, and then I press enter. And I don't know if you can see that, but if your calculator looks like mine. And so my answer here is going to be in full sentence. That after, so my initial investment, $1,400. So fathom this. If you have a savings account right now, and you put $1,400 in, and you could get the value increase by 9% each year. Good luck. If you find one, let me know. But if you put that in, after 25 years, you not touching it, your value would increase to $12,072.31. Okay? All right, let's look at number 3. So I'm going to write my formula over here. Y equals A times 1 plus R to the T power. And this is really one of those formulas that you want to memorize because you do use it a lot. So it says the number of student athletes at the local high school is 300. It is increasing at a rate of 8% per year. Use an exponential function to find the number of student athletes after 5 years. So my initial amount is 300. My rate is 0.08. And my time is 5 years. So I use this equation, and I'm just going to plug in values. Y equals 300, 1 plus 0.08 raised to the 5th power. And I'm going to let my calculator do the work for me. And in the magic of the calculator, when I type it in, now that you know how to do it, you should be getting 440 student athletes. Okay? So to save time for this, I do want to give you the answers, and I want you to work these out. I'm going to identify your information and tell you the answer for your notes, and then you can always check them with your calculator to make sure you're understanding. So if you look at number 5, population of a small town is 1,600, so my initial amount is 1,600. It's increasing at a rate of 3%, so 0.03, and we want to find the population of the town after 10 years, so my time is 10. So I get Y equals 1,600, 1 plus 0.03 raised to the 10th power. And when I do that in my calculator, I'm going to get 2,150 people. Okay? Now, that is exponential growth. Exponential decay, and we know decay is decreasing. So what does that formula look like? It's very, very similar. Y equals A. But instead of adding the rate, we are subtracting the rate. 1 minus R to the T. So A still stands for initial amount. R still stands for the rate. T still stands for the time. That doesn't change. But when you notice these word problems, we're taking away. It's pulling back. So that's why we have that subtraction there. So it said the population is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. We want to find the population in 2008. So my initial amount in 2000 was 1,300. My rate is 0.01. And the year, the time, is 2000 to 2008, so that's 8 years. So when I plug it in my formula, I have y equals 1,300. 1 minus 0.01 raised to the 8th power, and by the magic of a calculator, I can get 1,200 people would happen in 2008. So we started with 1,300 people, and at this rate, it's going to be down 100 people in 8 years from now. These are good. The value of a car is always important. So it says the value of a car is $18,000, and it's depreciating. It's going down in value at a rate of 12% each year, so 0.12. And we want to find the value after 10 years. So after 10 years. So now I have y equals 18,000. 1 minus 0.12 raised to the 10th power. And when I input that in my calculator, this is number 8, I get that the car value is worth $5,013.02. So after 10 years, that's my value. Now, if you have some fancy truck or, some car, it may not depreciate that much, but typically it's about 12% each year. Okay, so let's do 10. So an investment of 8,200. So my initial is 8,200. We didn't do so good in the stock market, so it's losing value at a rate of 2% each year. And I want to find out what happens if it goes in this direction after 9 years. So I put $8,200 away. I let it go. I don't know it's losing money. How much am I going to have after 9 years? So I get y equals 8,200. 1 minus 0.02 raised to the 9th power. And after 9 years, it would be worth $6,836.73. Okay? So that's the difference between exponential growth and decay. If you have any questions, come see me.